This is what your note page looks like front and back. Starting with the metals, shade in this area on your note paper. These are considered the metals. Now underneath your shaded area, fill in the blank. Metals are solid at room temperature. They have densities greater than water, except for the alkali metals, which is group 1. And they're malleable, ductile, they have luster, and they're good conductors of heat and electricity. They have low ionization energies and low electronegativities. Metals lose electrons so that they become positive ions with smaller ionic radiuses. The general trend is that metallic nature increases when you go from right to left and then down the periodic table. So it looks something like this. Metallic nature increases as you go down and to the right of the periodic table. Now look at the nonmetals and shade in this area in your note paper. These are the nonmetals. Nonmetals are gases or network solids at room temperature. Except for bromine, bromine's the only liquid in the nonmetal group at room temperature. Nonmetals are normally brittle. They do not have luster. They're very dull, and they're poor conductors of both electricity and heat. They do have high electronegativities and high ionization energies. They gain electrons so that they become negative ions. Now fill in the shaded area for metalloids. This is where you find them on the periodic table. Metalloids are sometimes called semi-metals because they represent a group that's intermediate to the metals and the non-metals. So they display both metallic and non-metallic properties. We also call them the semiconductors. You guys have heard of Silicon Valley, where they make semiconductors. And the last section on the front page is right here in the middle, and these are called the transition elements. These are the group 3 through 12 elements, and they're typically hard solids with high melting points, except for mercury. You'll see mercury in the middle there. It's a liquid at room temperature. Transition elements have multiple oxidation states, and that's because they can use their electrons from both these S sublevel and the D sublevels when they react with other elements. They're less reactive than the group 1 and 2 elements though. And when they do form ions, they're very colorful ions, so they're used often for fireworks. On the back of your paper, you'll be taking notes for ionic radius and what happens there. So here you have a sodium atom. Sodium has 11 protons and 11 electrons, but notice that that 11th electron is way out in the 3rd energy level, all by itself. See it? So basically what sodium does is it just loses that 1 electron, and when it does so, it ends up having an octet of 8 electrons in its outer shell that's left over. So sodium becomes an ion now because it now has 10 electrons and 11 protons. So it has a positive 1 left over. Notice also what happened to the radius. The difference between the sodium atom and the sodium ion is that the ionic radius is smaller because it lost that 1 electron. So the general trend with all metals, including sodium, is that the ionic radius is always going to be smaller because metals will lose electrons when they react. Looking at a nonmetal, what happens there is nonmetals gain electrons, just like here the chlorine atom is gaining 1 electron and becoming larger. So chlorine now has 18 electrons versus the 17 protons, so it has 1 extra negative charge. And it's become larger because it has more electrons. So the general trend with nonmetals is that they will normally get a larger ionic radius because of the fact that they gain electrons. So here's the difference between metals and nonmetals. You see the metals are in the yellow and their ions are in blue, so you see them getting smaller. And then the nonmetals are in the orange and the green, and you can see that nonmetals, as they become ions, are going to become larger. So the general trend is that the ionic radiuses increase from left to right on the periodic table, because on the left you have your metals and on the right you have your nonmetals. And I recommend that you draw the arrow across your reference table in your notes so that you can show this trend. Now on to the next box. You have groups or families that we're going to be looking at, and when you go down a group, the number of valence electrons is the same for every element going down that group. So what happens is that elements in a group will have similar chemical properties. Here's the first group. It's called the alkali metals. Here's the second group. It's called the alkaline earth metals. Each of these have similar properties. They're always found in compounds because they lose electrons real easily, so they're going to react very easily. They have low ionization energies and low electronegativities, and they increase reactivity when you go down that group. Group 1 is more reactive than group 2, and the very last element in group 1 is going to be the most reactive, and that's francinium. On to halogens. These are the halogens, so you want to shade those in on your notes. Halogens are very, very reactive, and because they're very reactive, they occur in nature only combined into compounds. Fluorine is the most reactive of the halogens. This is also the only group on the periodic table that contains all 3 states of matter when they're at room temperature. Fluorine and chlorine are normally found as gases. Bromine is found as a liquid, and then down one more you have iodine that's found as a solid in nature. Halogens gain 1 electron to become an ion that has a -1 charge. And they're commonly called the salt formers. The last group on your notes are called the noble gases, and you can shade them in like this. Noble gases do not combine with any other atom because they already have a complete energy level of electrons in their outer shell. We call that the octet. So we say that they're chemically unreactive. And another word for unreactive would be inert gases. Inert is like inertia. You may have heard of inertia before. Inertia is that property where objects have a tendency to stay at rest. Well, noble gases have a tendency to stay unreactive, so we call them the inert gases. Noble gases are very stable with their octet, and they are non-flammable because they don't react with anything. They're going to be non-flammable. This non-flammable property allows them to be used in fire extinguishers.